Hi everyone. I'm going to go through the Deciphering a Claim handout here, but the really important thing is the statistics table, because this table is literally how or what we're going to use to guide us through doing this. So back over here, the average yearly salary for those over 40 is more than it is for those under 40. So this statement is the null or alternative. So the average yearly salary for those over 40 is more than. So that more than is what lets us know that it is alternative. So the alternative, because there's no equality here, it's a greater than. So it's alternative because of the more than. The response variable is, so is it categorical or numeral? Well, because we're talking about the average yearly salary, that's an actual dollar amount. That's an actual number. So we've got numeral. So then, is it a basic inference problem, basic or advanced? Well, for this one, we need to know how many groups there are, because remember, basic for advanced, now bring the table over, basic is one or two groups or choices, and advanced are three or more groups choices. So basic versus advanced, well, over here, we only have two groups, the over 40 and the under 40. And technically, I guess it's kind of one group, but I mean, we're comparing those over and those under and their yearly salary. So it is basic. So because we know it's basic and it's numeric, we know that it's a student's T distribution. So we know it's that T distribution. So for the next one, we will use we know it's the T distribution because we worked our way through the table. The appropriate statistical method is, it's the independent means, but how do we know that? Well, let's see. We know that there's two groups. So right here, wouldn't be this one, wouldn't be this one. So right here, we know it's two groups, and we're comparing the groups to each other. So we've got two groups, over 40 and under 40, and we're comparing their yearly salary. So it is, and this is where you just look to see independent means, difference in means. It could be listed as any of these different things, but in this case, it's the independent means. So independent means. And then this is a left, right, or left to or right to tail, just means it's a both sides or both tails. So that's what two is. So left to or right, it is right tail because we've got more than is the alternative, and more than is a right tail test. All right, moving along, example 2. 33% of Republicans think that Hillary should be elected president. So this statement is the null, and that's because the 33% equals the number of Republicans who think Hillary should be president. So that equality makes it the null. The response variable is categorical, and that's because they just gave a yes or no answer. So even though 33% is a number, the number only represents those who said yes, Hillary should be president, and the yes is the categorical response. So whether this is basic or advanced, well, basic, how many groups do we have? Well, we just have one group. So it is basic. So one group because we just asked people, one group of people, what do you think, yes or no? So what kind of test? Well, that's, we work through the table. And so we know it's categorical because it's a yes, no. We know it's basic because it's one group. So we know it's the Z normal distribution. So there's our Z distribution. And then for which statistical method? Well, once again, we work our way through it here. So we know it's a basic, we know it's categorical, we know it's Z, so we know it's one of these two. Well, here we've got a one-way table with two choices, success or failure, or two-way with two choices for each group. Well, there's only one group, and they could either say yes or no. So it is the one proportion or single proportion test. So one or single proportion test. And then which side or which test, left, right, tailed, and it is a 2 because that equals is the equality, so that's the null. The alternative would be the not equals, and a not equals is a two-tailed or both-sided two-sided test. Okay, so example 3. A person's race is not a factor in average annual salary. So this statement is the null because we have is not a factor. So is not a factor is a null, because we're saying nothing's going on equal whatever, everything's the same. So is not a factor. It is numeral, once again, because we're looking at average annual salary, which is a number. But is it basic or advanced? It actually is advanced because the group is a person's race. Well, if you think about race, there's a lot of different potential races, definitely more than 2 races. I mean, yeah, you might say, oh, black, white, but there's all different colors, and you would have lots of different things that you would have to include in here. So definitely it's one group, which is people, but then the race is the 3 or more choices, because there's lots of different choices. So based on that, we know that it is basic, because we only have one group. Or we know that's a student, I'm sorry, we know numeric, we know basic because it's one group, which leads us to, it has to be the student's T distribution. So, oh, I'm sorry, I said this backwards. I was thinking of the other one. So we know it's numeric and we know it's advanced. Oh gosh, I'm sorry. We know it's numeric and we know it's advanced because it's 3 or more groups because of the race. Wow, we can tell I'm doing this on a Friday afternoon. So numeric advanced, we know it's an F distribution. So there's our F distribution. So then trying to figure out which test. So numeric advanced F distribution, which one of these? Well, for this one, more than 2 explanatory variables. I don't think there's any multiple regressions in this test, but two-way table, compare means of each classification. Well, this one you would have multiple choices from multiple different options, but for this one, we just have one group with 3 or more factors, and we're comparing the groups to each other. So it is the one-way ANOVA, difference in means. So there you go. And is it a left, right, or 2? Well, it is right, and that's because advanced tests are always right-tailed. So there you go. There is the walkthrough of deciphering a claim, understanding how you can get a lot of information on which test, what it is, and all of that from just one claim. But that also is why when you pick your claims and write your own claims, you have to make sure that your claim makes sense, because your claim gives us all of that information. So that's where you want to make sure your claim goes along with what you want it to do, or what you want it to be testing for. But I hope this helps, and good luck on your quizzes.